Hello, Dr. Bill here. Today we're going to take a look at a geometry problem that upon first glance seems to give some strange information. And I've entitled this When the Test Gives You Lemons. So we're going to see how to figure out how we make sense of this. So here we go. First we see that the note says figure not drawn to scale. And the question says in the circle pictured above, center O is a distance of 5 from chord AB. And again, a chord is a line that goes through the circle but not through the center. Okay, if the area of the circle is 69 pi square inches, what is the length of AB in inches? Okay, and again, if you're not quite sure what to do when you have a geometry problem, the secret is to just start putting down what you do know, and eventually it's going to lead you to where you need to be, right? The other thing I notice here is that there are 5 answer choices. This is indicative of an ACT question. ACT math questions have 5 answers, while SAT math questions have 4. So let's take a look at this. So the first thing that I notice is that the area of the circle is 169 pi, right? So this means that we can find, if we kind of draw a radius here, and we can draw another radius here, we've actually constructed a triangle. And it says that, again, the area of the circle is 169 pi. Now, the area of a circle is found by multiplying pi times the radius squared. So here we have a pi on both sides of the equation. We can cancel it. So 169 equals r squared. So then r would equal the square root of 169. And that's a perfect square. The square root of 169 is 13, so r is 13. So now we have that the radius is 13. We can look at this on both sides. And then they're asking us what the length of the chord AB is, right? So hopefully those of my students who've paid attention to the other geometry videos have realized that already. This is one of these special Pythagorean triples, right? And in a Pythagorean triple, we have certain common combinations of sides. And I'll write them all down, but this one would be a 5, 12, 13. 5, 12, 13. And we can prove that with a Pythagorean theorem. But the thing is that if you remember your triples, it's just a lot faster, right? So I'll write the other common triples in a moment, but let's just prove that this is right. If you did not recognize that this is a 5, 12, 13 right triangle, we can find this side again by using the Pythagorean theorem. So that is a squared plus b squared equals c squared. So let's call our a here 5, so 5 squared. And our b squared would be what we're looking for here. So we're going to say b squared equals 13 squared. We have to remember that with the Pythagorean theorem, the hypotenuse, which is to say the side opposite the 90-degree angle, is always the longest side. Okay? So this means 25 plus b squared equals 169. Again, we bring that 25 over the other side, so b squared equals 169 minus 25, which is 144. So then b would equal the square root of 144, which is indeed 12. Okay? So this measures 12 and this measures 12. So that means that the chord AB is going to be 24. Be extremely careful here, right? When we found 12, that was for this side of the triangle, but there are two of them here, so 12 and 12 would be 24. Okay, now the other common Pythagorean triples that we need to remember would be 3, 4, 5. Again, these are not, these are not involved in the problem here. 3, 4, 5, that's a 4, right? And then 6, 8, 10, the 5, 12, 13 that we did do here. And then the other two are 7, 24, 25, and then 9, 12, 15. Okay? So there we have it. The measure of this chord is 24. I hope you found this brief lesson on geometry helpful. If you did, again, please subscribe to the channel if you have not. Hit the like button, the bell icon, and notify you of future videos, and kindly share with anyone who could benefit from this video. This is Dr. Bill. Thanks for tuning in, and we will see you on the next video.